Thanks, Andy, for the introduction, and thanks everyone for showing up at the Spark Summit today. It's really great to have you all here. And as Andy said, we are sold out with over 1,000 people, which is the largest Spark event yet. So I'm going to start by just showing a little bit of what's been happening in the Spark community and where the project is going. And it's an easy talk to give because this year has been an extremely exciting year for Spark. So let me just start with some of the highlights of this year. So this year we've seen very fast community growth. We've seen more people start contributing to Spark, more organizations start using it than any other year before. We had our 1.0 release in May, which was a major milestone for the project. And we also saw significant commercial adoption and use of Spark. There are at least 7 companies now, 7 distributors of big data technology offering Spark. There are at least 20 applications we've counted that you can buy, enterprise applications that are built on Spark. So just to compare the activity a little bit to what happened in the last year, I'm going to show a few statistics from 1 year ago in June 2013. So at that point, the project had already been going for a while, and it actually was a fairly active project. We had, since the project started in 2009, we had 68 contributors at that point. I counted 17 companies contributing to it. There were slightly more because I can't figure out where every contributor works. And we had about 63,000 lines of code in the project. Now, this year, all these numbers are actually a lot higher. So we recently reached over 250 contributors to the core project. Just this month alone, there are something like 30 new contributors who sent patches to Spark. I've counted at least 50 companies that have contributed to the project before I stopped counting them because I couldn't figure out where people are from. And also, we have almost 3 times the amount of code. So there's been a lot of activity in terms of the features and capabilities that Spark has. Compared to other open source projects in big data, Spark is extremely active. So this year, we actually became the most active project in the Hadoop ecosystem, and also the most active project as far as I can see in the big data space in general. This graph here shows the commits to different projects over the past 6 months, and this graph over here shows the number of lines of code changed. So you can see, even compared to highly established and fairly fast-moving projects such as the Hadoop file system or Yarn, Spark actually has a factor of 2 higher activity. And this is over the past 6 months. Actually, if you look closer to, say, 3 months or 2 months, the difference is even higher. So Spark has quickly gone from a research project at a university to the most active project in the Hadoop ecosystem. And actually, the level of activity is really high even compared to other open source projects in general. So at the Apache Software Foundation, we're one of the top 3 most active projects. And also, compared to other data processing software that's widely used, evolving quickly and is not even necessarily for big data, so projects like NumPy, Matplotlib, and scikit-learn, Spark has more monthly contributors and more commits going in per month. So there's a lot of activity and excitement about the project. And the final thing I want to say about that is that the community is also growing. So it's not just that we hit some kind of top point and then there's some that everyone who's contributing and who's building stuff is happy with what's there. Actually, we're continuing to see very fast growth. And this month alone, we had something like 74 different people contribute to Spark. What's really exciting about this is, the Hadoop space and ecosystem has been around for a while, and other projects in the space, like HDFS and Yarn and so on, also have increasing activity. But since Spark started out, it's managed to meet and then surpass these projects. And to us, that means that we're really doing something that's interesting to people and that is hopefully bringing more people to the ability to work with big data than the ones who are using just Hadoop initially. And we've definitely seen that in a lot of our users. Spark is the first big data project they start with. And that's really exciting to us because the whole goal of building Spark was to make big data easier to use. That's what we're hoping to do. So next, I'm going to highlight just some of the major additions that went over the project in the past year, just to show a little bit of what's going on. So at the last Spark Summit, which was in December, we talked a little bit about how development was going and what at least some of us at Databricks were working on. And we said that we wanted the project to focus on two areas. One is building standard libraries of algorithms and functions. So instead of you just writing the algorithm from scratch against the processing engine, you can just call it from a library and have a high-quality implementation available. And the second one was enterprise features. As more and more enterprises started adopting Spark, things like security, high availability, and monitoring, and so on became important. So we've done a lot of work on both of them. In terms of libraries, we had 3 new standard libraries that came into the project this year that all see very high level of activities. First, there's Spark SQL, which was added in 2014. There's MLlib, the machine learning library, that was actually added in September of last year. And there's GraphX, graph processing, which was also added at the beginning of this year. And I'll talk a little bit about them later. There's a lot of activity in all of them. In terms of enterprise features, some of the ones that have come in over the past 6 months are support for the Yarn security model, much improved monitoring features, and high availability for the master in Spark. So these are all things that make it easier to deploy. So I don't have a lot of time to talk. I'm just going to highlight 3 features and 3 new things in Spark that I think are some of the most exciting that came out to give you a sense of what this work has been trying to do. So first, I'm going to start with one of the libraries, which is Spark SQL. So Spark SQL came out in Spark 1.0, and it addresses a very common problem that we saw users have, which is loading and querying structured data in Spark. So when you start to write a big data application, you don't just start in a vacuum. You probably have data that's in some kind of storage system already and has some kind of structure associated with it. And normally getting the data out of this into something like Spark or MapReduce or whatever else has been fairly painful. For example, to use Hive, you had to figure out where the files are in HDFS and then start querying them, make sure you have the right input format, all that stuff. With Spark SQL, you can query a lot of common data sources very easily from directly within your Spark program. So this code snippet here shows how to connect to Hive. Essentially, you just create this Hive context object and then run whatever select query you want against any Hive table, whatever format it's in. We figure it out from Hive, and we bring you that data. And then you get those objects back, as in this case, these are Python objects, and you can just start using them directly, just a couple of lines of code to start using Hive. The same thing is actually now possible for JSON, and this will be released in Spark 1.01. I think everyone, about half of the early users I worked with in Spark were trying to use and import JSON and had to write all this code with Jackson and like all these crazy libraries to work with it. And with Spark SQL, you can just point it at a JSON file. It figures out a schema that looks like your records, and it lets you just query them directly. Spark SQL actually does a lot more than just loading in data. So it also ties closely with Spark's language APIs, and you can not only get data from these structured systems into your programming language, but also put functions from your programming language into SQL and use them there. So this snippet at the top is showing how to create a user-defined function in Python, and compared to any other system where you try to create UDFs, this is one of the easiest ways to do it. You can just register your Python function and use it. And most importantly, for applications built on Spark, Spark SQL provides a uniform access interface regardless of what they run on. So you can run the same application on a Hive cluster on HDFS or on a JSON data set sitting in S3 and just access data in the same way. And this project is, fairly new. As I said, it was basically released in March, but even then, it's had 44 contributors over the past year. So it's one of the most active areas of development in Spark. Second library that I want to highlight that's gotten a lot of adoption is the machine learning library, or MLlib. We started this one in the fall of last year. So here we wanted to have a standard library of machine learning algorithms. Machine learning is one of the most interesting and sort of high potential things to do with big data, but actually coding up these algorithms beyond the demo to something that really works properly, that uses the correct version of the algorithm, is very difficult. So in MLlib, we're providing high-quality implementations of over 15 algorithms now. In the last release, we added 3 or 4 of them. I'm not going to just list some many-letter acronyms there. Even now in development, there are 5 other major algorithms that are in pending pull requests to go in. And all these algorithms, you can use them in Spark in just a couple of lines of code. So this project's also been very active. We've had 40 contributors since it started in September, and it's, again, one of the most active areas that we see contributions in. And finally, the third thing I wanted to highlight is the language APIs. And one of the really exciting things to come in the last year is support for Java 8, and in particular, the very concise function syntax available in Java 8. So traditionally, if you use Spark and Scala or Python, you had this really easy syntax. It was really quick to put together a program. And now it's possible to do the same thing in Java. And of course, Spark still works with older versions of Java as well. And that's been kind of a tour of the features I thought were really exciting. At the rest of the talks, you'll see a lot more detail about specific ones. So the final thing I wanted to cover then is what is our vision for Spark and what is our goal? Where do we want it to go long term? How does it relate to other big data projects? And in this part, I'm going to show you two aspects of that vision, 2 ways of looking at it. So the first way is as a unified platform for big data applications. Now, I think most people have seen this kind of picture before. So Spark, one of the things that makes it unique as an engine is that it can support many distinct types of processing in the same engine. So you can do batch processing, interactive queries, and streaming, and also actually more complex things like iterative or multipath algorithms. So that's one way that it's a unified platform, because you can combine and stitch together these workloads, and any real-world pipeline actually tends to use multiple ones of these. In the past year, something really exciting that's been happening is also underneath Spark, where it can run, and unifying the different runtime environments for big data. So traditionally, Spark has run in the Hadoop environment, HDFS and Yarn. It can access all these, both of these, and it can run very well along these. But there are a lot more big data systems and runtimes than Hadoop. One of the really cool ones that we've been working with in the past year together with DataStax is Cassandra, being able to very quickly query data in Cassandra. And a lot of great support for that is coming up. You'll see in some of the future talks. Of course, Spark can also run on Mesos and other cluster managers. And we've also seen a lot of activity in cloud platforms with people starting to push support for things like OpenStack and definitely Amazon Web Services and so on. So that's what it can run on. And what's really great about this is that using Spark, you get a uniform API for these different workloads on all these different runtime environments. So if you write an application, you can combine it with streaming or batch applications. You can also take that application, and as I was mentioning before, take it from running against Hive data to running against JSON data in S3, and it's very easy to just move it around. And we're seeing a lot of applications start to use Spark as an engine to do this and actually run over the whole space of big data systems. We think this kind of platform is really interesting. It's somewhat surprising that there isn't really a standard one like this already for big data. The closest thing is maybe the MapReduce API, but that only handles the batch workload. And this platform is important for developers because it means there's only one system to learn. It's great for users because it means they can take their application and run it against data sources and environments anywhere. And it's also good for distributors of these things because they get a wide variety of applications that can run on top of them. So that's the first way we want to see Spark. A lot of the work that's gone in lately has been to expand its abilities as a platform. And then the second goal I want to set out for it is building a standard library for big data. So big data applications are quite difficult to write today, partly because there aren't standard libraries, like the libraries you get in Java to do a lot of basic computing stuff. You get thousands of libraries that come in from Sun. In systems like R and Python, you get thousands of libraries that you can link to, but there isn't anything really like this for big data. And Spark is a great place to build this kind of library because it's a general engine, so you can run the algorithms in many modes, and also it supports multiple programming languages, so it's a great place to see that. So when you look at Spark today, it is one system, one open source project, but within it we increasingly have more and more of these libraries, and we've been working very hard to make sure these libraries work well with each other and meet the criteria of robustness and capabilities that you expect from a standard library. And all these libraries are increasingly being exposed in more languages. We have Python, Scala, and Java today, and there's also ongoing work for R. So if you look at the project today, most of the activity is in the libraries. In fact, it recently changed from core to being libraries, and we also expect this to continue in the future. So that's kind of what I wanted to say about Spark. One final thing I'll do is I'll say one slide from the perspective of the company, Databricks. So at Databricks, we have a lot of the core team that created Spark, and we are 100% committed to making it open source, making it compatible across all vendors and distributions, and giving you this experience of a platform for big data that you can use everywhere. All of our work in Spark is in Apache. We're continuing to do it. You can just go to GitHub and see what we're working on right now. And I don't have time to go into any of the ongoing work, but check out the talks both from us and from the rest of the community to see what's going on. So that's all I wanted to say, giving you an update of what's been going on. Thanks for coming, and enjoy Spark Summit.